Okay, so I'm going to go over synthetic division, and this is something that's best learned by watching it be done in process versus trying to learn it from the textbook. This is just really hard to learn it by looking at the textbook because it's hard to explain what you're doing and how to like put it in a set of steps. But before we get started, I'm going to review long division of polynomials because synthetic division is like a shortcut to doing this process. So I'm going to do the long division process so that you can appreciate that we have a shortcut. So we have here negative 10x squared plus 2x cubed minus 5, and then divided that by x minus 4. So when you do long division of polynomials, you have to rearrange everything so that it goes from the highest exponent to the lowest exponent. So I need to have my 2x cubed first, then my minus 10x squared, and then my minus 5. Now I actually like to put in a 0 term. Sometimes you don't need it, but I do like to put in a 0 if there's something missing. Like we don't have an x term, so I'll just put a 0x just as a placeholder. And then let me write a better line here. We're dividing this by x minus 4. So when we do long division, we're always looking at the first terms basically and dividing them. So we're looking at, okay, 2x cubed, we're dividing that by x. And when you divide that out, you get 2x squared. So 2x squared is what we write on top. That's basically what we need to multiply by in order to get 2x cubed. So then you multiply your 2x squared that I wrote on top there. So let me write what I'm doing. I did 2x cubed divided by x. And we use our rules of exponents, and that becomes 2x squared. Then you take that 2x squared and you multiply it by x minus 4, and that's what gets put in the bottom, like underneath your polynomial. So when you multiply that out, you get 2x cubed. So I write that underneath the cubed term. And then I have 2x squared times negative 4, and that gives me a negative 8x squared. So you write that underneath. And then you draw a line, and then you change all of the signs. So I put circles around them to remind me that I've changed them. So everything that's positive becomes negative, every negative becomes positive. And then you add them together going vertically. So 2x cubed minus 2x cubed is 0. Then I have negative 10x squared plus 8x squared, that's negative 2x squared. And then you just drop down your next terms. And then you repeat the process. And this time you do it with the negative 2x squared. So you're taking that first term, and let me switch colors. I'm taking that negative 2x squared, and I'm dividing it out by x, which gives me negative 2x. So I write that on top. Then I take that negative 2x and I multiply it by my x minus 4. So when I distribute that, I get negative 2x times x, so that's negative 2x squared. And then a negative 2x times negative 4 is a positive 8x. So I draw a line, then I change all of my signs. If it's something that's positive, I will kind of add a little negative there to remind me that that's negative when I change the signs. And then negative 2x squared plus 2x squared is 0. Then I have 0 minus 8x, so that's minus 8x. And then I drop down my minus 5. And then we repeat the process again, this time with the minus 8x. So I've got my minus 8x divided by x, and that gives me negative 8. So I have a negative 8 up here. And then I take that negative 8 and I multiply it by x minus 4. and you distribute. Negative 8 times x is negative 8x. Negative 8 times negative 4 is a positive 32. I'm kind of running out of room here, but you draw your line, you change your signs, and then I've got negative 8x plus 8x is 0. Negative 5 minus 32 is negative 37. And then I can't remove an x from that, so that's like my remainder. So once you get to a point where you can't remove x anymore, then you write your final answer. So you look at what you have on the top, 2x squared minus 2x minus 8. Got a better looking 2. And then I have my remainder, and that gets written as a fraction. It's negative 37, and then I divide it by x minus 4. And this is what your answer looks like. And this is what long division is. When you do long division of polynomials, it gets long. There's a lot of steps. There's a lot of intermediate things that you need to write down to make sure you're doing all your multiplication and everything correctly. A lot of people don't like doing this process, which I understand. It's kind of tedious. I've always found this process kind of fun, but most people are not like me. So most people do not enjoy this kind of process. So we have a shortcut to this, which is called synthetic division. So the thing is, though, with synthetic division is that it doesn't work every time. It only works if you're dividing by certain things. So they have to be in the form of x minus or x plus a number. So if you have a fraction and you're trying to reduce a fraction and that's in the bottom, you can use synthetic division. Or if you're dividing, you can use synthetic division, but it has to be in that form. If there's a number in front of the x, if you have an x squared you're dividing by, you can't use synthetic division. So then you have to use the polynomial long division. Luckily for us, what we're doing in this class, most of the things that we need to do, we're dividing by an x plus or minus a number. So we can use synthetic division for most of the things that we're doing this week. And next week, there is going to be one thing next week where you have to do the long division. So you do have to learn that process. But most of the time, synthetic division is enough, and that's what we need to do. And what synthetic division does is it basically ignores all of the variables that we have here, and it only does the math with the numbers, the coefficients. So it ignores all the variables, and you're looking at just the coefficients, and you're just multiplying and adding. It's like it's taking, let me get the highlighter here. It's like you're taking your multiplication steps and then these adding steps that you have right here. You're focusing only on those. You're multiplying and you're adding. You're multiplying and you're adding, and you're skipping everything else, and you're ignoring all the variables. And it makes it very compact. You don't have to take up a lot of space, and it's really quick to do in your head because all you're doing is multiplication and adding. And it's just easier to follow. You don't have any of these variables. You know, you're less likely to make mistakes. So that's what synthetic division is. It's just multiplication and adding. So there are multiple ways that you can set up the synthetic division. The textbook has one way. I do it another way, and I've actually seen other textbooks do it a third way. So just be aware that there's multiple ways to set them up, but it all comes down to doing the same thing. So let's say we're given some problem where we have ax cubed plus bx squared plus cx plus d. So we just have some polynomial, and we're dividing it by x minus c. So we're just going to use, we don't have any numbers here, we're just using placeholders to kind of show you where everything goes. So the coefficients from the polynomial that you have, that's basically, if it's in a fraction, it's the top of the fraction. Those go across here, or like I do it more in a table form, which is a little bit easier if you're trying to like type things up because it's really easy to make a table. But they go across there. It's just those coefficients. And then in this like little area here, that is whatever makes this part equal to 0. So if it's x minus 2, then you would put 2 in the spot that I have highlighted with that's green. If it was x plus 2, you would put negative 2 because you're putting in what makes it 0. Whatever would cancel that out. And then this first number always gets dropped down. So whatever the first coefficient is always gets automatically dropped down. So that's how you initially set it up. And I'm going to always set it up the way on the right because that's just that's my natural way to do it. So we've got it set up. And then what you do is you multiply and you divide. So you multiply these two numbers together. And then in the textbook, they write it underneath B and you add those. So you multiply these and then you add going down, and that gets you this answer. So in my way, I actually multiply across like this, and then I just write it on top. I just do it slightly differently, but then you add, and that gets you your answer here. So you're multiplying and then you're adding, and then you continue the process by multiplying the same C by your next number that you have underneath. So you would multiply C by whatever your addition result was, and then that gets written in the next spot, and then you add those going down. So you take this, multiply it by that number, that result gets written on top, and then you add it going down and you have a new number right here. And then you repeat the process. You once again multiply, and I'm going to just do what I have on the right, C times whatever that number is in the box. That answer gets written on top the next part, and then you add them going down, and then that gets you a new number, let's say a triangle. So you're adding and you're multiplying and adding. So I set up with like the variables so you can kind of see, okay, I'm adding what you're multiplying together. It gets complicated when you do these with all the letters. It's easier when you actually have it with the number, but that's the process. And you just keep going until you've kind of filled in every spot. And that's what synthetic division is you're multiplying and then adding. So once you've filled in your little chart, then you have to figure out, well, how do I have all these answers. How do I get what do I do with them? I have all these numbers. So I've kind of filled these in. And so like here, I'll do my way. You multiply C times A, that gets written on top. You add together, and that gives you a new number E. And then you can see, okay, you multiply C times E, that gets on top. Add it to C, you get a new number F. And so I have it written so you can kind of see that pattern, and then I'm just labeling the new number as a new letter. So you've got these numbers now that are in the bottom here. So whatever is in the last spot is always your remainder. And so if you have a remainder, that will always be put on top of a fraction. Just like we kind of did with that long division. So whatever that final number is, that goes on top of a fraction. Then this basically forms your polynomial. So that gives you the coefficients for the part that doesn't have a fraction. And you start with a constant, which in this case is f, and then you just add an x. So whatever number I have at f is a constant, so there's no x. So then I know my next one's going to have 1x, and then the next one's going to have 2x. And that's how you can get your polynomial. As you kind of fill in and you count as you go to the left, so you get another extra x, and then those are all the coefficients. And that's how you read your answer. And this will, I'm going to go through the process, but I wanted to make sure you at least had all this written down. So synthetic division is dividing. So you can see that it gives you something with like a part without a fraction and then with a fraction. Same thing that we got with the long division. Now there's a lot of vocabulary that you need to know with these things. So when we do long division or synthetic division, we get what's on the left, divided form. And so just whatever is on the top of a fraction or whatever you want to divide by or divide into is called the dividend. And then what you're dividing by, which is on the bottom, is called the divisor. The part in our answer that has no remainder, that is not a fraction, is called the quotient. And then we have the remainder over the divisor. Now, one of the nice things about synthetic division is that we can use it as a way to factor. And so we can then go into factored form based off of what we did with our divided form. So you can always write your answer in factored form if it asks for it. And when you do that, the top of the fraction is whatever you're trying to factor. So our dividend, whatever the top is, let's say that's something we wanted to try to factor. What we're factoring out is the divisor. We multiply that by the quotient, whatever had no remainder, and then we add our remainder at the end. So it's just a different way of writing our answer. And these are equivalent, but it depends on what the question is asking you for, whether they want you to just divide or they want you to factor. So you need to pay attention to the vocabulary because it tells you what form you're putting in. Now, every example that I'm going to do is going to be dividing. So I'm only going to be putting it into the form on the left because we're not getting into factoring polynomials yet in this video. That's a whole separate video. But when you get to finding zeros and factoring polynomials, that's when you're going to start putting them in factored form. But I'm just going to be doing divided form. So let's get started. So you can see it as a fraction where you're told to divide, or you can see it written out with the actual division symbol. So here we see it as a fraction, and we're dividing the top by the bottom. And so what you do is you take your coefficients, you ignore all the variable parts, and you want to write them in basically in a row. So I have a 4, a negative 15, 11, and a negative 10. And so I'm going to do it my way, where I just basically make a table like this. Then we have on the bottom x plus 3. So what I use for synthetic division is what makes the denominator 0. It's basically the opposite sign. So if it says x plus 3 there, I'm going to use negative 3. And then that first number always gets dropped down below. So that's going to be 4. So whatever's that first number always gets dropped down. So that is the initial setup. Then all you do is multiplication and division. So I multiply the negative 3 times 4, and that's negative 12. And then I take negative 12 and I'm adding it to negative 15, or basically negative 12 minus 15. That gives me negative 27. Then I repeat the process. I take negative 3 and I multiply it by negative 27. So I'm going to use my calculator for that. That gives us 81. And then I add 81 plus 11, and I get 92. Then I repeat the process. Negative 3 times 92. I get negative 276, and then I add it to this negative 10, or I subtract 10. That gives me negative 286. And now I have nowhere else to go. I filled in my every spot, and so now I just have to write my answer. So that last spot that this is our remainder. So I know that I'm going to have a negative 286 over, and then we're dividing with our fraction here, x plus 3. So that's the denominator, x plus 3. And then I have my 92, which is the constant. So I can just put that in right there. And then I'm going to just go from, continue writing from right to left. I have a plus. So the negative 27 will have an x. And then my next term is going to have an x squared. And then that coefficient is 4. So I make sure that I'm counting as I go from right to left, my exponents are counting up, or basically they're counting down as you go from left to right. And that's your final answer. And you can see that this process is faster than doing long division, and it takes up less space than long division. And you're just looking at the numbers. And so those people that really struggle when you throw variables into things, like this is much easier because it's like, oh, I don't even have to worry about the letters. I just look at the numbers. Do you guys have any questions? Okay. So here's another one. And so here it's written in an alternate way where we actually use the division symbol to say that we're dividing. So again, I'm going to take my coefficients and first set those up. So I have 2, negative 7. Now, I don't have an x term. I have to put a 0 there. So notice it went from x squared to the constant, and there was no term that had an x. You have to put a 0. If you don't put a 0 there, it's going to mess everything up, and it's not going to work. So you have to put a 0 placeholder if you have missing terms. So what we're really looking at here is 2x cubed minus 7x squared plus 0x minus 65. So that's why I have to put that 0 in, because you need to make sure that you're taking care of any missing terms. And then we're dividing it by x minus 5. So I can rewrite this as a fraction. And so if I have x minus 5, I'm going to use 5 in my synthetic division because I'm using the number that makes it 0. 5 minus 5 would be 0. So this is how you set up this problem. You have to put in a 0, otherwise it doesn't work. And then you've got your number that you're basically dividing out in this case, which is 5. And then that first number that I have drops down so that I have that 2. And so now I just do my multiplication and addition. So 5 times 2 is 10. And then 10 minus 7 is 3. 5 times 3 is 15. 15 plus 0 is 15. 5 times 15, that one I can't do in my head, 75. 75 minus 65 is 10. So filled in my chart. Now I need to turn this into the actual answer. So again, that 10 is our remainder, 15 is the constant, and then we have all these other terms. Now, if you don't like having to write it from right to left like I did on the previous example, you can go from left to right. This is going to be, we start with an x cubed. You're removing an x in your answer. So that's going to be the x squared, the x, something without an x, and then your remainder. So you can kind of write those in to help you. So we get 2x squared plus 3x plus 15, and then 10 over x minus 5, because we're dividing by x minus 5. there any questions? Okay. Here's another one. We've got x cubed minus 52x minus 95, and we're dividing it by x plus 6. So I'm going to take the coefficients. Now x cubed, we don't have a number in front, so we're going to use 1. And then I don't have an x squared term, so I need to put in a 0. So you have to think about these things as you write it down. Then I have minus 52, and then minus 95. And then we're dividing by x plus 6. Negative 6 makes that 0, so negative 6 is what I'm going to put in my chart. And then I'm just going to drop down the 1. So then from here, it's just our multiplication and addition. So negative, yes, go ahead, Wilmer, before I move on.
Also, my question is, why did you move the 0 to the second spot when 95 is on the third spot on the top?
So that 0 is for our x squared term. So in our original problem, we don't have an x squared, so I have to put a 0 there. You always have to count down. So my x cubed had a coefficient of 1. There was not an x squared, so I have to put 0. Then I had an x, which had a coefficient of negative 52, and then negative 95 is now the constant. So that's the last part. So where you put zeros depends on what is missing. So like in this case, what we're missing was an x. So that's why the 0 was in the third spot, because when I counted down, I had x cubed, x squared, and then I didn't have an x, so I had to put a 0. And then my minus 65 also ended up in that last spot again. So the constant always ends up in the last, but where you put zeros depends on what is missing in your polynomial. So you have to kind of look at what's missing. So does that help? Does that answer your question?
Oh, yes, it did. Thank you.
Okay. So, yeah, I could help to actually wrote what I wrote there, if that helps you out. I'm going to erase that because that's where I put my multiplication. So that's how we have it set up. So now we're taking our negative 6 and multiplying it by 1. And that gives us negative 6. And then negative 6 plus 0 is negative 6. And then I take my negative 6 and multiply it by negative 6. That gives me a positive 36. 36 minus 52 gives me negative 16. And then negative 6 times negative 16 is 96. Then 96 minus 95 is 1. So I actually, as I'm looking at this, I must have had a typo because I meant to put a 96 here because I wanted this problem to have no remainder, so that you have an example of no remainder. So we're going to just make that a 96 so that we can get this to have no remainder, because that was what I was trying to do. I just typed the wrong number. So I want to show you what happens if you have a 0 there. So if your last spot ends up with a 0, that means there's no remainder at all, and it goes into it evenly. So when you divide it, you don't have a fraction part because there's no remainder. So now when we get our answer, so again, this first part started with x cubed. We're removing an x, so our answer is going to start with x squared. And then we're going to have an x, and then we have our minus 16. So our answer is x squared minus 6x minus 16. And then there's no remainder, so you don't have to write that fraction part. And so this divides out evenly. Are there any questions? Okay. Well, I actually have only one more example because, once you do enough of these, you kind of get it's pretty straightforward, and you'll get plenty of practice once you start finding zeros of polynomials and everything. So this is my last example. We've got -5 plus 2x plus 5x cubed minus 2x to the 4th over x plus 1. Now, when I put it in synthetic division form, I can't put it in any way that it's written. I always have to have it go from the highest exponent to the lowest exponent. We need to make sure our polynomials are in standard form. So I need to actually rewrite the top of this fraction and put the highest exponents first and count it down. So I've got -2x to the 4th. That's the highest one. The next one is 5x cubed. Next would be an x squared. I don't have an x squared, so I'm going to put a 0 there. I will need a placeholder for that one. And then I have 2x. Then I have my -5. So I'm just rearranging it so that my exponents go from high to low. And then I'm putting in any zeros if I have missing pieces, because I'm going to need those zeros in my synthetic division. So once I've rewritten it, now I'm going to take my coefficients. I have -4, 5, 0, 2, and -5. And then the denominator, we're dividing by x plus 1. So -1 will make that 0. So we use -1 in our synthetic division. And then I drop down my -2. So are there any questions about this setup before I go forward here? Okay. So now we do our multiplication and division, and I encourage you in your notes to even do this step and see if you get the same answers as I do. -1 times -2 is 2. 2 plus 5 is 7. -1 times 7 is -7. -7 plus 0 is -7. -1 times -7 is 7. 7 plus 2 is 9. -1 times 9 is -9. -9 minus 5 is -14. So it's easy to make a mistake here. So, you can always double check your math. But if you write down your numbers that you get, that's pretty easy to double check that if you accidentally multiplied wrong or something like that. So most of the time when we have these, they always end up with a remainder because it's very hard to get something that has no remainder. And in this case, it would be very helpful to write in all of your x's so you can figure out what you've got. So we've started with something that was x to the 4th in the highest term. We just divided out something with x. So now we're going to have something that's an x cubed, and I'm going to just write in those coefficients or those x pieces to help me remember how I'm putting this in. So I get -2x cubed plus 7x squared minus 7x plus 9, and then that last part is my remainder, -14 over x plus 1, since I divided by x plus 1. Any questions? Okay, so that was my last example. So this is synthetic division, and you'll be using synthetic division in a lot of the things that you're doing this week. You use synthetic division to factor polynomials. You use synthetic division to find zeros of polynomials. You use synthetic division you can even use it to find function values of polynomials. There's a whole bunch of theorems that involve using synthetic division, so it's going to be used a lot. Depending on how far you've gotten in the material, you may have already been working with some of that stuff. But basically, we use it most of the time when we're trying to factor a polynomial, and you do your synthetic division. If you get a 0 in your last term, like if there's no remainder, like here, that means you just factored something out and then you factor again. So like in this case, we were able to factor out x plus 6, and if we were trying to factor, we would then take our answer, x squared minus 6x minus 16, and then you would factor again, because that's a quadratic. So when you use synthetic division to factor, you're basically trying to remove something that works that makes you have no remainder. You get an answer, and then you repeat the process again to factor, and you keep going until you can't factor anymore. So synthetic division helps with that, and because synthetic division is less work, it doesn't take up as much space, it makes this whole factoring process easier, because otherwise if you try to do long division to factor out, you would probably use pages upon pages upon pages of paper. But if you use synthetic division, you can do several types of divisions on the same piece of paper. You're not using up as much, paper, and it's much more consolidated, compact. But there are videos out there for that. That's a whole nother video doing the zeros and everything. And I think I actually have a video on that, on finding zeros with polynomials. So any other questions that you guys have?